So here are the answers to the third midterm for AP Statistics. This is the one you guys just took. Today is January 21st. Midterm was on chapters 2, 6, 7, 8, and 9. So here's question 1. Got weight of eggs produced by a breed of hen is normally distributed. Okay, so we've got some information already. The population is normally distributed. The mean is 65 grams, so I'm going to write over here mean is 65 grams, and the standard deviation is 5 grams. Think of cartons of such eggs as simple random samples of size 12. Okay, so sample size is equal to 12. So the first question, if a particular carton of eggs chosen at random weighs 804 grams, so that means the total of all the x's, the observations, the weights of the eggs, equals 804 grams, what's the weight of an average egg? And we don't want to deal with the carton. So the average egg, sample mean, because we're taking a sample of size 12, is 804 divided by 12, which equals 67 grams. So the average egg weighs 67 grams if the carton weighs 804 grams. Okay, so now we move down a little bit, and this is where people get confused. What is the probability that the average weight of an egg in a sample size of 12, we're taking a sample of size 12, remember that, falls between these two values? What we're looking at is the probability that x bar is between these two values, like that. So what kind of distribution does x bar have? According to the central limit theorem, and according to the conditions and assumptions, x bar is normal. The mean of x bar is equal to, what was the mean of the population? 65. So the mean is equal to 65, and the standard deviation is equal to 5 divided by the square root of n. Don't forget that, guys. We're looking at the distribution of a sample mean. So we need to find the standard deviation of the sample mean. This simplifies to normal mean of 65, standard deviation of 5 over square root of 12, which is equal to 1.4434. Okay? Now it's easy to figure out the probability. If we draw the picture of it here, like this, the mean is 65, the standard deviation of x bar is 1.4434. We're looking for this area. We're looking for that area right here. So we can use a normal CDF function for that. Let me bring my calculator up. Poof, it's like magic. That's what the pause key can do for you. Take a look at normal CDF from 62.5 to 68 3/4 with a mean of 65 and a standard deviation of 1.4434. And you get an answer of this probability is equal to, 95.37, so 0.9537. Okay? If you got an answer of about 40-some%, you used the wrong standard deviation. You have to remember, you always need to ask yourself, the standard deviation of what? The population or of the sample? In this case, it's of the sample. Question C, a little tricky question on my part. If you take a look at the total weights here, the total weight of the carton, question A kind of led you to believe that you can't find this probability. Well, you can, it's just not easy. What you do instead is take these two and make them sample means. If the carton weighs a total of 750, you can divide it by 12, and if you divide it by 12, you get 62.5. If you get 825 as a total weight, divide that by 12, you get 68.75. And lo and behold, these are the same two numbers as the two numbers in question B. So this probability is going to be the same as the probability in question B. It's the same question. I'm just asking you the probability and the weights between, or the weights of the total weight of the carton, not the average weight. So that's the difference. Answers to B and C will be the same. Okay, good. The one thing we didn't do on this question was check the conditions and assumptions, and I'm not going to worry about that so much now, but starting with the next chapter, chapter 10, we're going to be checking conditions and assumptions all the time. If you were to do that for this one, you would be looking at simply the following. Since the population is normal, okay, it's given in the problem, then X bar is normal also. And you can just say stated in the problem. And you could answer the conditions and assumptions. We don't have to worry about sample size on this one. Because the population is normal, that's what's stated right here. All right, so there's question 1 for you. Here's question 2, but I probably don't have enough time to do this, so I'm going to go ahead and stop it, and we'll go on to part 2. Okay, so go ahead and check out part 2.